In today's lesson we're going to be looking at complement of an event. Now that essentially means an outcome that isn't something. Now easiest way if we think about this is if we have a dice and if we have an event A rolling an odd number, then the outcomes we have for that are 1, 3 and 5. So if A is the event, the complement of A, so the things that aren't A can be represented by A with our little dash here. And we know that the things that aren't A, so the ones that aren't odd, are the ones that are left over. So that's 2, 4, and 6. And we're going to look at a little bit later about how we can show that both A and the complement of A can be put in a Venn diagram. But let's just get used to using these terms as a starting point. So we've got a sample set of numbers here, 1, 2, 3, 4, and 5. And let's just say that those numbers might be a spinner. So when you spin, you've got an option of bringing up one of those numbers. So if the event is A, so A is equal to 3, the things that A is not, so the complement of A would be 1, 2, 4, and 5. Okay, pretty simple. So again, if we have a look at B, what we're going to do is list what B is. So B is squared numbers. So in this data set we've got 1 which is a squared number, and 4. So that means everything left over, the complement of B, is going to be 2, 3, and 5. Okay, so our last one here, we've got our C event listed, and the complement of C is going to be, well, we've got 1, we've got 2, 3, and 5, so the one that C is not is 4. Let's have a look at a different example here and how this can be applied to a Venn diagram. So we've got a Venn diagram here and we've written down the numbers, the outcome that they come in, and this could be anything. It could be, say, 2 events such as the number of people playing marbles and the number of people playing netball. So what we're asked to do here is write down the number of outcomes for each of the following. So if we have a look at M, what we need to do is find out how many people are playing M, so marbles. So what we're going to do is find out how many people are in this circle here. So everyone in that circle is going to be playing marbles. So we've got 6 plus 11, so the number of people playing M is 17. Okay, so now we need to look at the number of people that aren't playing. So if we can see here, we've got the complement of M, which we've just spoken about. So how many people are not playing M? Now, if we take out all the M's, the complement of M is anything that's outside of M. So that would include this space here and the space around the outside. So we've got 15 plus 4, which is equal to 19. So sorry, we just changed pen here to hopefully make this a little bit cleaner. We've now got this new little symbol, which is basically an upside down U. And if you look at it, what it's saying is that it wants you to find which of the people are doing both M and N. And if we look at it from the Venn diagram perspective, it's going to be this section here in the middle, because these people in the middle are both playing marbles and netballs. And the way we actually write all these is we write N, M, M, N, and we can see from that shaded space that equals 11. Now what we're looking for now is the number of people here. Sorry, we'll change pens again. So in this example D here, we're looking for the number of people that are both M but not N. So as a starting point, what I'm going to do is shade in the whole of the M area. So we're looking at M. But we can see from this second part we need to also add in the people that are not, all those things that are complement of N. So that's not going to include all these guys in the middle because they're actually playing N. So you can see it's just going to be that space there. If we have a look at the number, that's going to be 6. And in our last example here, we're asked to identify the people that are not M and the people that are not N. So that's going to be everybody left on the outside. And that's 4.